Okay, we are going to move along and we're going to go to the next half of 1-6. The next half, we're still talking about absolute values, but now instead of equations, we're going to have inequalities. Okay, just like 1-5, where we first solved equations and then inequalities, we are now going to solve absolute value with the inequality instead of the equation. So this is just a continuation of 1-6. Inequalities, remember, when you are solving an inequality, if you multiply or divide by a negative, you have to flip the sign, just a reminder, and pretend the inequality is an equal sign, and then you have to solve each case 1, case 2, exactly the same. Exactly like you did equations, except now we have inequalities. I also have given you steps to solve inequalities because the end is a little bit different. Okay, up until you get solve each case, steps 5 and 6, these are new, okay? And that's what we're going to talk about now. So let's go ahead and use the steps, and I'll help you get through solving absolute value inequalities. Step 1, isolate the absolute value. What does that mean? Get the absolute value by itself. Pretend it's a variable and get rid of everything else. So I have a times 3 here, so I'm going to go ahead and divide everything by 3 so that the absolute value is not by itself. 3 divided by 3 cancels, so I have the absolute value of y minus 9 is less than 9. Okay, so now I still have to do my case 1, case 2 with what I have left. So y minus 9 is less than 9, and then I have case 2, I forgot to write down case 1. I have y minus 9 is greater than negative 9. Now why would I flip the sign? Because if you remember, anytime we make it negative, we have to flip the sign. So in that case 2, when you make that negative case, you always have to flip that sign. Don't forget. So solve both cases. So we're going to add 9. Okay, this is where I'm at. I forgot to determine if the absolute value is even true, and it is. A positive number that is less than 9. Okay, case 1, case 2, and now solve each case is what we're doing right now. So I have y is less than 18. Sorry, I kind of backtracked there. And this one, plus 9, plus 9. So I have y is greater than 0. So what we do now is different than what we did when we had equations. When we had equations, we had to check both answers to make sure that it actually worked. Now what we have to do is actually take these two inequalities and graph them on a number line like a compound inequality. We have two inequalities that have to be true in order for this absolute value to be true. So let's look at this. 18 and 0. Y is less than 18, so here's 18. Open dot, and it's going this way, but y also has to be greater than 0, so that one's going this way. What kind of compound inequality is this when both of them are, when the two inequalities run into each other? Is it an and or an or? It's an and. So we would say y is less than 18 and y is greater than 0. Remember, and inequalities, you can also write 0 is less than y, because the y is what's in the middle, which is less than 18. So either answer is acceptable. And sometimes if you're doing like a multiple choice problem, you might not have this option or this option. You'd actually have to just choose whichever one is acceptable. All right, let's do another example. I'm going to go full screen this time. Okay, so first thing I have to do, if you remember back to your steps, and if I were you, I'd write down those steps. Step 1 is isolate the absolute value. So I'm going to subtract 2 first, get rid of your subtraction and addition. Okay, and so I have 1/4 absolute value of x minus 3 is less than negative 1. And then I have to multiply both sides by 4, because to get rid of divided by 4, or 1/4, and multiply both sides by 4. So I have the absolute value of x minus 3 is less than negative 4. Now if you remember the step that I skipped earlier, I said make sure before you do case 1, case 2, make sure that this inequality can be true. What does that mean? Well, absolute value measures distance, correct? So can the distance, whatever you put in here, be less than negative 4? No, it cannot. You cannot have a positive number on this side that's less than a negative number. So in this case, there's no solution. Okay, a lot of times what will happen is you guys will do all this work and you'll get the answer wrong on the test or on Math Excel. The reason is you never actually checked to see if it was possible or not. So make sure you don't skip that step. Check to see if it's possible. All right. Step 1, isolate the absolute value. Get it by itself. So we're going to add 3 to both sides. So I have the absolute value of x plus 5 over 3 is greater than 6 plus 3 is 9. Okay. Now, check to see if it's possible. Is a positive number, can it be bigger than 9? Absolutely. So we're going to go ahead and do our case 1, case 2. So case 1, I have x plus 5 over 3 is greater than 9. And remember, case 2, my negative case, you have to flip that sign. So I have x plus 5 over 3 is less than negative 9. Go ahead and solve both cases. So if you look here, how do I get rid of divided by 3? Multiply both sides by 3. This cancels. So I have x plus 5 is greater than 27 minus 5 is x is greater than 22. Solve this side. Multiply both sides by 3. I have x plus 5 is less than negative 27. Subtract 5. X is less than negative 32. Now that I have both of my inequalities, I have to decide, do I have an and or an or situation for my final answer? So I'm going to go ahead and graph it. Graph both of them on the same number line. X is greater than 22, so here's 22. Greater than, open dot, it's going this way. And negative 32 is over here. Open dot, and it's less than. So it's going this way. So do I have an and or inequality? Well, since the arrows are going in opposite directions, one or the other one is true. So our compound inequality solution is an or. Okay, something that looks like this, and you will see this on your test in Math Excel. How many times is a positive number greater than a negative number? No matter what number I put in there for x, negative 1,000. Is it going to be greater than negative 1? Absolutely, because here we're going to measure distance. This is actually positive 1,000 because of the absolute value symbols. No matter what we put in for x, it's going to work, whether it's a negative or a positive. So this is our answer, all possible solutions, or the number line, the entire number line. Sometimes Math Excel will have different ways to say that. They'll say x is in the set of all real numbers. They will say all possible solutions, all kinds of things. So just know that if it's greater, a positive number is always greater than a negative number. All right, now we have our word problems. These you have to think about. All real numbers less than 3 units from 0. All real numbers less than 3 units from 0. So what I always recommend is that you put this one before you have your answer, put it in a graph. So if I have a graph here, all numbers less than 3 units from 0. Well, if this is 0, and this is 3, and this is negative 3, 3 units from 0 is going to be all of this. But it can't include because it has to be less than. So what does that look like? That's an and. So we have negative 3 is less than x, which is less than 3. So there's my inequality. Now how do I write my absolute value? Well, the absolute value of x has to be less than 3 units from 0. That helps me out. But just work it backwards. Let's look at this one. All real numbers at most 6 units from 0. So let's graph it. All real numbers at most 6 units from 0. So that's 6 and negative 6. So that means at most. The most it can be is 6 units. So it does include 6 and negative 6. Okay? But it can't be more than that. So it looks like this, which is also an and inequality. So we would say, okay, negative 6 is less than or equal to x, which is less than or equal to 6. And in that case, we're just going to have x. That right there. All real numbers more than 4 units from 6. All real numbers more than 4 units from 6. So if this is 6, 4 units this way, 7, 8, 9 is 10. 4 units this way, we have 2. All real numbers more than 4 units from 6. So it has to be here and it has to be here. Has to be more than, all real numbers more than. So this is an or. So x is going to be greater than 10, or x is going to be less than 2. And this is a little bit more difficult to write in an absolute value. All real numbers more than 4 units from 6. So if I think about that, we have an or, so the absolute value has to be more than 4 units. The distance has to be more than 4 units. The distance from what? The distance from what? From what? Well, 6. So it'd be x plus 6 is greater than 4. So let's double check that. So if I have x plus 6 is greater than 4 and x plus 6 is greater than negative 4, I'm sorry, not greater than, we gotta flip the sign, less than negative 4. Okay, what we have is, if I subtract 6, oh, I messed up, it needs to be minus 6. All right, let's look at that again. It has to be minus 6. So we have x minus 6 is greater than 4, and x minus 6 is less than negative 4. Now, when I solve, if I add 6, does it work? X is greater than 10, plus 6, plus 6, x is less than 2, which is exactly what we have up here. So that would be our final. And what I suggest to you is, like I did, I made a mistake there with my sign on the inside. Go ahead and check it to make sure that your two inequalities match. All right, moving along. All real numbers at least 3 units from negative 2. So let's try this again. All real numbers at least 3 units from negative 2. So if this is negative 2, 3 units away would be at positive 1. 3 units away would be at negative 5. So at least 3 units. So it has to be 3 or more. So we have another or situation. Okay, so at least anything in here would be not at least 3 units away. So what happens is we have x is less than or equal to negative, less than or equal to negative 5, or x is greater than or equal to 1. So let's think about that. We know that the distance has to be more than 3 units or equal to 3 units away. And I know that negative 2 has to go in there. Well, if I put in x, we'll try minus a negative 2, which actually changes it to plus. Let's see if that works before we consider that our final answer. So I have x plus 2 is greater than or equal to 3. So my case 1 would be x plus 2 is greater than or equal to 3, and x plus 2 is less than or equal to negative 3. Minus 2, so x is greater than or equal to 1. Minus 2, x is less than or equal to negative 5, which is exactly what we have up here. It checks out. That means this is my absolute value inequality. And that's it. 1-6 worksheet 2, and then once you finish that, go ahead and complete the Math Excel. Your quiz will be assigned on the 18th.